Hi, this is the solutions for Chapter 13 homeworks number 47 and 51. So in 47, we're asked to find the lowest degree polynomial in standard form that has the given zeros. So the issue here is that we have this imaginary zero. And for us to have a polynomial with integer coefficients, we need to have also its conjugate. So I'm going to also include the 0 2 plus I square root 3. So what I do then is I'm going to take each of these zeros and treat them as a solution for x. And by subtracting them, everything onto one side, what I have is a polynomial that's equal to 0. And you'll notice when I do the subtraction for these imaginary parts, I'm going to treat them just as like one whole number. So I'm just going to put a parenthesis and a negative sign out front when I move it to the other side. You don't have to do it that way, but I find that that's a little bit easier for me when I do that. And then what I'm going to do is I have a polynomial whose solution is 3. I have a polynomial whose solution is 2 minus I squared 3. And I have a polynomial whose solution is 2 plus I squared 3. And if I multiply those polynomials then together, what I'm going to get is a polynomial that has all of those solutions. So again, I've multiplied all the left-hand sides together, and then I multiplied all the right-hand sides together. And since the right-hand sides are all 0, it just is equal to 0. What I'm going to do now is I'm going to FOIL out these two pieces that have the imaginary parts. And if I FOIL these out, I should get something that is a polynomial with integer coefficients. So if I multiply x times x, I get x squared. And then I'm going to multiply x times, multiply x by negative the quantity 2 plus I squared 3. Again, you could do this where you don't have this extra set of parentheses in here, but this is just the way I like to do it. And I do the same thing here, so I'm going to get, and then I multiply those out. Okay. So now I'm going to distribute my x here. So remember there's a negative sign in front of that x, so I have to make sure I'm taking that negative with me. And I'm going to distribute this x here. Again, that's a negative in front of it, so I got to make sure I take that with me. And then I have to FOIL this out. But the nice part here is, if you notice, this is in the form of a difference of 2 squares. So I don't really need to FOIL it out. I just know that I'm going to get a squared minus b squared. So really what I'm going to get here is 2 squared minus I square root 3 squared. And so if I combine things here, I notice that I have a negative I squared 3x and a positive I squared 3x, so those are going to cancel out. I can combine a negative 2x and another negative 2x to get negative 4x. I know 2 squared is 4, and I know that I square root 3 squared is going to be 3I squared. And I know that I squared is negative 1, so I have really 3 times negative 1 or negative 3. And then I have a negative of a negative, so that's really plus. So I have a plus 3 there. Oops, but I forgot about this 4 there also. So 2 squared is 4, and then minus a negative 3 is 7. So that's probably the hard part, and then I'm just going to multiply these two polynomials out. So multiply the x to all the different places. So I have x cubed minus 4x squared plus 7x, and then multiply the negative 3 to all the places. So I have negative 3x squared plus 12x minus 21. So I have x cubed minus 7x squared plus 7x, oops, I meant 19x minus 21. So there's my polynomial. Okay, so the worst part is just kind of doing the multiplication back out. And it's just more annoying than anything else. For number 51, what we're asked to do is to find all the zeros for the polynomial, both real and non-real, and if any zeros are repeated, to state the multiplicity. So I'm going to start by looking at my possible rational solutions. To find those, I'm going to look at all the factors of the constant term, which is 2, divided by all the factors of the leading coefficient, which is 1. So that's just plus or minus 1 and plus or minus 2. The only factors of 2 are 1 and 2. 1 divided by 1 is 1. 1 divided by 2 is 2. And they can be positive or negative. So what I'm going to do now is I'm going to type in this polynomial into my calculator. And I'm going to look at the graph. When I look at the graph, what I'm going to be looking for are x-intercepts, but the only x-intercepts I care about are going to be the ones that are also on this list. X-intercepts that are not on that list would be things that are irrational, and that's not going to help me because I can't do synthetic or polynomial division with an irrational. It's not going to be fun. So it looks like I see some x-intercepts here, but it's really hard to see them. So I'm going to readjust my window. So maybe I'll go from negative 2, oops, I think I said negative 2 to 0. And then maybe I'll just go from negative 1 to positive 1, because all I really care about is what's going on at the x-axis there. So it looks like I definitely have an x-intercept at negative 1. And that's all I need from the calc, is to see that. And that was the only x-intercept we saw there, right? There's nothing else that we could see. Again, if I go back and look at that standard window, the only place where we had a crossing was going on right here. So that's the only real solution to this, or real zero, I should say. So I'll go ahead and start my synthetic division with negative 1. And that's worked, right? Because I got a remainder 0, so I know that x plus 1 is a factor. And I still, what I'm left with here then is x cubed plus 3x squared plus 4x plus 2. And this is still not something I can factor by grouping, right? You could try it, but it's not going to work. So that means I need to do another synthetic division. Well, the only 0 I have to work with is negative 1. There weren't any others on our calculator that were possible, so I just have to try it again. So that worked. So now I have factored down to here. And since now I have this factored into linear and quadratic pieces, to find the zeros, I can just set everything equal to 0. And solve So the x plus 1s, that's easy to solve. There's not much going on there. For x squared plus 2x plus 2, I'm going to use the quadratic formula. So that's negative b plus or minus square root b squared minus 4ac all over 2 times a. So that's negative 2 plus or minus 4 minus 8 over 2. And 4 minus 8 is negative 4. And remember that when we're square rooting a negative, that creates an imaginary number. That gives me an I. So that gets rid of the negative sign. And then the square root of 4 is just 2. So I have 2i plus or minus 2i. And notice that both the parts of my numerator, the negative 2 and the 2i, are both divisible by 2. So I can reduce this down to negative 1 plus or minus I. So I have the solution negative 1, and I got that solution twice. So that has a multiplicity of 2. And then I have the solution negative 1 plus I. That has a multiplicity 1. That only happened once. And then I have the solution negative 1 minus I, which has a multiplicity 1, because I got that solution just one time. And that's my answer. So if I look here, I got 2 solutions. I got 2 here because I have the plus or the minus, so that counted as 2 solutions. And I had 2 solutions here because the negative 1 I got twice. And if I look at the degree of this polynomial, it's degree 4. So I should be getting exactly 4 solutions if I'm counting the multiplicities and counting the imaginaries. So at this point, I'm quite confident that I've done this correctly. If you're ever in doubt, you could do the same procedure that we did in the previous problem and multiply everything out to see if you get the same polynomial here. That seems like a lot of extra work for something, but if you wanted to check it, that would be the best way to check it. The other possibility would be you could plug in the solutions into this polynomial and make sure that they all evaluate to 0. But again, doing that with the imaginary pieces is going to be kind of a pain in the tuchus, right? You remember from last chapter how we had to do a imaginary number to an exponent was not trivially easy to do that. So like negative 1 plus or minus or plus I to the 4th was going to be kind of an ordeal to get through. Wouldn't have been bad, but it's a little bit more trivial than just plugging in 7 or something. Okay. I hope that helps, and good luck.